Right. Is everybody able to see my screen, the notepad screen?
Yes.
Thank you. Right. So, as Swami just told, he just gave a very minute and short brief about what OSI model is. So, in this class specifically, what I'll be trying to tell you is the basic of networking, the basic from where actually how the actual traffic flow is for each and every packet according to the OSI model and what is the DoD model with respect to the OSI model, right? So as we begin each and every class with the history of how it started and all, this particular session is also the similar one. Now coming to the OSI model, basically you need not remember all this. This is just a basic brief what I'll be giving just for 1 or 2 minutes, and then later we'll go ahead with a very demonstrative class for how actually the OSI model actually works and how each and every layer is very important for delivering the packets. And guys, if you have any doubts, then and there, just pause me, ask me doubts, not a problem. Additionally, if you are not understanding any terminologies, like if I'm telling packets, if I'm telling TCP, UDP, whatever it is, you can just pose a question in the chat section. I'll answer to that later on as well. If you are uncomfortable unmuting yourself, not a problem. You can just post a question in the chat, right? So let's begin. So basically, this OSI model is just a reference model. That is important. It's just a reference model in order to see how the packets are actually going, how the packets are actually being delivered to the end host, and how the packets from the end host are coming back to the application, right? So this was developed in the 1984 as a reference model by the International Organization for Standardization, that is ISO, right? Now, what does this OSI model consist of? It consists of totally 7 layers according to OSI model, right? In this, the top 4 layers, if you see 1, 2, 3, 4, application, presentation, session, and transport, these are called as the application layer or the software layer, right? So if I highlight this, I think that's not the right color. So from 7 to 4, these are called the software layers, right? Or the application layer. Why they are called as application or software? Because they are on the system. They are not a hardware component of the architecture of the reference model, right? The all the these three layers are called as the hardware layer because they are the hardware components of the network model here. However, the third layer can also be considered as an application and also be considered as an hardware. So you need not be worried about that. You can ignore this. You can just remember that the below 3 layers or the lower 3 layers are the hardware layers and the upper layers are the software layers or the application layer. So basically, this is what OSI model is, right? Now, why there is so much importance on OSI model, and why do we need to learn in the beginning of any network session using OSI model? It's simple. Let's come based on in a scenario manner, right? Let's say you live in a gated community, right? And you want to deliver a parcel, or a courier boy has come and he has to deliver a parcel. How will you do that? He will first know your he will first get the package from the courier service. That is, it could be somebody, let's say A is a user who wants to send the packets to the B user, right? So this A user will align some courier boy here to send the traffic, to send the packets or the parcel to the B user, right? So what this particular user will do here is he will give the a parcel to this particular courier boy. His or her job is to send it, deliver it without any damage to the B user, right? So how that will be done is this particular user here will give the package to the courier boy. The courier boy knows the address of B, right? So he reaches to the address. Let's say this B user lives in a gated community and there are n number of houses here. Let's say some 20 or 30 houses are there. And this particular user, this particular courier reaches here. Courier boy, he reaches here. Now, how will he deliver the packet to the correct user who is living in this particular block A? How will he deliver that? So to deliver that, he must know where this particular user actually resides. So he will go and then deliver the packet only to A. He'll not go to each and every house and knock their door asking where should I deliver the packet or where should I deliver? Are you B? Are you B? Nothing like that. They have to know the address of this. So this is just a basic overview. Now how it will work in concern to OSI model. Let's say you're writing an email. Okay. Let's say you're writing an email and while you draft an email, it is into the application layer, right? It's into the application layer. Application layer is nothing but your own GUI. GUI is nothing but graphical user interface, right? A graphical user interface is nothing but, let's say you go to Gmail, you are trying to compose an email there, right? When you compose an email, you will get an interface, right? Like from to CC and then the subject line, and then you draft the email and then you apply your signature and then send it. So that is a GUI, right? So in the application layer, you will have the contents in many, n number of protocols will be there, n number of protocols, n number of data will be there, which the other layers do not understand, in fact, right? So application layer is a very crude layer where the other layers will not understand anything about what is going on in the seventh layer. Now, this seventh layer's job is just to get the input from the user. So let's go step by step. That is, one person is sending an email, right? One person is sending an email. So during the email is being drafted, it is in the application layer. In the application layer, you draft the email. Your job is done, and you hit the send button. Once you hit the send button, it will then inquire in the next layer, which is our presentation layer. The job of this presentation layer is to comprehend whatever data is there here in the seventh layer. So in the seventh layer, we have, I just told you that there are many protocols which are there, which the other layers will not understand, right? So let's say you draft an email, which is in the format of a JSON format. So no need to worry, guys. This is just a protocol, not a problem. So it's in a JSON format or in an ASCII format. ASCII is nothing but it's an American standard for the interpretation of each and every detail. Let's say if you write 10, if you write 10 in ASCII format, it is written in the bits and bytes format, sort of a thing, right? So like that, it is. This is called as an ASCII format. So no need to worry. So let's say this is a protocol. This is a content what we are getting from application layer. Once it comes from application layer to presentation layer's job is to comprehend that data or compress it. Compress it because it doesn't understand what that data is. Its job is to just compress it and then or compress it or encrypt it. Right? Compress is nothing but whatever data you are getting. Let's say you're getting around 10 MB of data. So I believe everybody is aware of size, right? MB, GB and all.
Yes.
Yeah.
Yes.
So this is 10 MB of data. Now this particular 10 MB, the whole 10 MB will not go through the network. This is going to create a lot of congestion and cause network latency when it reaches the end host, right? Let's say you're trying to download 1 GB file of data. When you download a 1 GB file of data, 1 GB file of data will not come at a time to you. It will come in fragments or it will come in segments, right? So we'll come to segmentation and fragmentation in a short while. However, I'm just giving a high level architecture here of how the OSI model is actually working and what are each and every functionalities of each and every layer, right? Now this particular 10 MB file will be compressed to the to the amount which it can be compressed to. Let's say this 10 MB file is compressed to only 5 MB size of file, right? And then it is kept there in a hashed format. Now, what is hashed format? Hash is nothing but, let's say you have a file. Let's say you have got a document file, right? Application layer knows that this is a document file, but presentation layer won't know that it's a document file. What it does, it will hash this. Hash in the sense it is not completely cutting it or something. It is just making a hash value of it. And then this hash value will be in a form of numbers and alphabets. So alphanumerical value will come for this hash. So hash has its own standards like MD5 hash values, right? MD hash values. So this MD is message digest, right? So like that, it is going to hash whatever content is coming from layer 7 to the layer 6, right? So these two layers job is done now. Now the next job of the fifth layer, that is our session layer, what it does, what it does is it is going to initiate a session for sending this particular email to the recipient to whomsoever you have sent this email to, right? So when this seventh layer has done its job of drafting the email, which actually you actually typed this email, and then later the job of the OSI model or the internal application is to send it to the presentation layer so that it compresses it or encrypts it and creates a hash value of it, and then it passes that along to the session layer. So session layer is nothing but where you are going to initiate a session. Here it will use session initiation protocol. Now let me give you a very short example for about this call itself. So everybody have joined this call. We have a number of users on this particular call. Let's say 10 users are there, among which I drop off the call, right? If I drop off the call and I rejoin the call again, I'm able to come back to the same call, right? I'm not joining into another call where other users are there or it's not related to this meeting. So how is it happening? It is happening because of this session initiation protocol. The job of this session initiation protocol is to maintain a session intact until and unless this flow is completed. So what it will do, it's going to keep a port open, keep a session open until and unless the job is done. So this session will be open. So let's say our example, let's say we have Google Meets server here and everybody are sitting here, right? I am sitting somewhere here, right? So everybody has joined this meeting via Google Meets, right? Everybody has joined this meeting. Even I myself has joined this meeting. Suddenly I drop off, right? I drop off. What mode I have to join the connection back? I have the meeting link. So I go to that meeting link. The meeting link verifies my identity that, okay, this particular user is supposed to join this particular meeting. And then it again connects me back to the same meeting where you people are there. I am not connected into some other meeting where other users are connected to the same meeting server, right? So the initial job of this session initiation protocol or the session layer is to create an session for that particular data to be transferred. The next job is a basic job, not very important, but the next job of this particular layer is authenticate the user. Authentication. So I believe, is everybody aware of authentication?
Yes. To identify the person, I think.
Yes, that's it. To identify if that particular person is actually the person who he says he is. So basically, authentication is something which each and every person will require everywhere, even the banks, even offices, even this service provider, let's say Google Meets in our scenario, right? So this is how this authentication will happen. And that depends on how this particular server is requesting the information. In our scenario, none of you have logged in using ID and passwords. You might have just logged in using the meeting link and then given your name there and then you join the meeting, right? So that depends on how the server wants to accept the connection. So that's how this session layer does its job. So any doubts until now, until this layer, any doubts? Or if I'm confusing you, you can pose the question right away so that we can clarify it. No doubts? Right. Let's go ahead. Now we have drafted the email, we have compressed it, we have initiated a session. What's the next job of this particular packet or this particular traffic, whichever is coming from your browser when you draft an email? When you draft an email, you send it until session initiation protocol. The job doesn't stop here. It has to go through your Wi-Fi, your network towards the end user's Wi-Fi or network, right? So how does that happen? Now here we have the next layer, which I think Swami mentioned that it's the heart and core of the OSI model, that is transport layer. Right? So what's the biggest job of this transport layer? The biggest and the important job of this transport layer is to send data in a very corrected form. There should be no error in the data. So why I asked you and I stopped here at the fifth layer is because I wanted to explain about error-free concept of sending the traffic, right? So what I told you that when the data is generated in the seventh layer, I told you that in the presentation layer, it gets compressed, it gets broken, it gets encrypted, right? So once this packet is encrypted and broken, this particular data, once it comes to the transport layer, its job is to send the data without any errors. So how does it do that job, right? How does it do that job? It has to create some way of reassembly or a segmentation of the packets. So let's say we had 5 MB bytes of data which was compressed. It comes to this particular layer here in the transport layer, and this 5 MB is divided into these blocks of data, and each block of data has a specific ID in which it will be reassembled when the packets reach the destination host. So for now, what you have to remember is that transport layer's job is to send data in a very reliable manner. That is, there should be no error. So this is the layer which actually looks at if there is any error in the delivery of the data along the when the packets are transported, right? So in transport layer, we have two important protocols, that is TCP and UDP. So TCP is known as a reliable protocol and UDP is known as a non-reliable protocol. So the major difference between TCP and UDP is reliability. And by reliability, what I mean is, let's say you send 10 bytes of data, or let's say in our crude scenario as of now, 10 packets from let's take users. Let's take A and B users here. Now, this A user is sending 10 packets to B user, right? So when these 10 packets are going along the path, so this is internet. There are n number of routers in the internet, right? Through which this data has to go to the B. So let's say B is in United States and A is in India. So you know that there is a lot of distance in between India and United States. But still, whatever email you are sending, whatever messages you are sending, it reaches the recipient, that is B. So now in our example, we are sending 10 bytes of data or 10 packets. Once you send this 10 packets, how will A know that whatever initial packet, so let's say first packet is being sent to B, how will A know that first packet has reached? Any guesses, any idea? Let us take an example of our courier boy only. How does this A know that this courier agent deliver this packet to B? How does he know? I
IP
believe
address, by using the IP address or any MAC address.
no, no.
Will receive message.
So any more idea? Any more guesses?
We will receive
Using the
message.
server.
Sorry.
We will receive message.
Server.
No.
Yeah, we will receive message. That's one. Another one. I think Lakshmi was talking.
Using the server.
Using the server. I didn't get you. Server. What will server do?
Like it is connected to different servers, right? Using IP address or something servers. It might
Uh,
know.
yeah. Yeah. Yeah, that's not correct. That's not exactly right. But let me just clarify that. So, when we receive a parcel, what we do? Let's say an Amazon courier boy comes at your home. You pay him, and then the next thing he asks you to sign that particular copy, whatever it is. Whatever delivery you get, they will ask you to sign if you have received it or not, right? So this is a form of acknowledgement you are giving to the courier person, and this courier person will send the same copy to A, telling that here is the sign of B, telling that the packet has received, that the parcel has received. So that's the simplest way of acknowledging the packets. Now comes the concept of acknowledgement. So here as well, what does TCP do is it waits for acknowledgement packet to come back. When I mean by acknowledgement packet, this is a technical term. You can make a note of it. Acknowledgement packet. Guys, everybody is taking notes, right? I didn't mention that.
Yes, we are taking.
Yeah, you can take brief short notes, whatever you feel is out of context or you haven't heard any time. Make a note like what I am writing on the screen here. Later on, I'll provide some or the other resource. It will be provided to you. You can go through that particular resource, and Google is obviously there from where you can fetch more data, right? So any doubts in this, let's say if I'm telling acknowledgement, make a note of it. If you have any doubts, let me know. I'll clarify that. So now the job of this first packet, once it reaches B, B tells that I acknowledge it. I received first packet. Great. Now send me another packet. Then A will send the second packet. It sends second packet. B tells I received two also. Great. Now, once these two packets go, A is very confident now. Okay, great. Now I think so. I can send at a time 3 or 4 packets. Let me send 5 packets. Now he sends 5 packets at a time, but B acknowledges only for 4 packets, right? Once this acknowledgement comes for only 4 packets, now A is of an opinion, oh, now this particular user didn't receive a 1 packet. So this means that 1 packet was lost during transit. So that can happen, right? That can happen. That can happen how? So here is one router, here is another router, here is third router, and user B is sitting here and user A is sitting here. Let's say 5 packets are being sent from here like this, right? So it is sending the packets like this, and suddenly the packet gets dropped here somewhere in between these two routers. The packets get dropped. So only first packet went, second packet went, third packet went, fourth packet got dropped here, and fifth packet went. Now user B saw that you are sending me 5 packets, but I only received 4 packets until now, right? So now what A will do, it will realize that okay, there is a transmission loss somewhere, the packets are lost. B did not receive the packets what he or she has to receive. Let me resend the packet. So A will resend that particular packet back to B. Now this is why TCP is called as reliable. So that's it. That's it. This is how the error free packet flow happens in TCP. But basically, I'll come back in depth regarding each and every layer. There are multiple protocols. In application layer, there are protocols, presentation, session, transportation layer, and further we have further 2 or 3 layers in which protocols will be there, which are really important. We'll come back to each and every protocol in depth shortly during our classes further when we go. But giving you a very high level brief how the packets are going today in our first class, right? So here the TCP is called as reliable. The reason being this: I know multiple users. I mean, you might not have understood this. If you are not understanding it, please ask me right away, because this is something which you must know by heart. It should be this should be understood. It should be like you should know what is TCP doing actually, right? If any doubts, just make sure that you ask me the question at the end of the session. Now let's come back to UDP. Why we call UDP as a non-reliable protocol? So it's also a transport protocol only, but still we are calling it as a non-reliable protocol. Why? The reason is simple. Here we do not receive any acknowledgement from the end user, that is B. Let's say we are sending around 10 packets from this to B, right? From A to B, we are sending 10 packets. We send first packet, we send second packet, we send third packet, we finally send 10 packets, but B only received 8 packets, right? During transit, 2 packets were lost. But A is not concerned whether B will receive all the packets or not. Its job is done. It sent 8 packets, that's it, job done. It sent 10 packets, khatam. I will not send further more packets to you. There is nothing else missing from my end. That is what A will tell. B will not receive the next 2 packets. The reason being, it is not sending acknowledgement. That's not in UDP. UDP never acknowledges for packets, right? So by packets, I mean the network packets. These are network packets, right? So this is how UDP and TCP differ from each other. TCP is a reliable protocol, reason being their acknowledgements. UDP is a non-reliable protocol, reason being there is no acknowledgement back. But still, it is considered as a very good protocol because now you are on call with me, right? You are using UDP. You are using UDP. Let's say, what if we are using UDP and suddenly you have internet connectivity issue? So there are packet drops, there is latency in your network, and you have sometimes this happens, right? When you're on call, the call gets stuck and you miss whatever the host was telling. Let's say now I'm telling you something, I'm telling you A, B, C, D, and suddenly you get a network drop and you only hear XYZ, that's it. So you miss the remaining alphabets, right? In between. It did not come back to you. So I believe I'm making sense here. It did not come back to you because there is no acknowledgement. There is no acknowledgement, and the server will not send the packets which were lost during transit again back to you, right? But if the call was connected over a TCP session, that wouldn't have happened. In that manner, what would have happened is whatever you missed, that will be repeated back to you. That will be repeated back, and also the ongoing session also will be there. So there will be a clash between the current packets and the earlier packets, and that would cause issues when you're on a call, when you're talking with somebody on a Zoom call or on a Google Meets call, something like that. That is the reason why for all the live sessions or live packet sort of architecture, we use UDP protocol to keep that flow, to keep that call intact without any sort of disturbances, right? So I believe you have understood what is UDP, why is UDP non-reliable and why is TCP reliable. Everybody clear?
Yes.
Great.
Yes.
Okay. Any queries, you can make a note of it. You can let me know later. No problem. Right. So we have now, let's come back to our initial scenario, how the OSI layer functions. We have drafted email, we have compressed it, we have sent it to the session initiation. Now comes the transport layer where it is transporting the packets using the ports, right? So in TCP, we have ports. We have 2 to the power of 16 number of ports. So around 65,000 approx, right? So these many ports are there in TCP or UDP, right? So because this particular layer is a 16-bit layer, 16-bit header, which has around 2 to the power of 16 bits of data in it. I'll come back to this calculation and what's the significance of this in next further classes. Not to worry about this calculation as of now. So there are 65,000 ports on user machine, and by user machine I mean your devices, your mobile phones, your home desktop computers, laptops, everything. So each network interface card on a user machine has those many ports, 65,000 number of ports. And these ports, each port has a relevance of it. So from 0 to 1024, 1024, these ports are reserved, so you cannot use this port because these are used by different protocols. So I'll also mention regarding that in the later class because this will get confusing now, right? So this is the basic thing. So this NIC means network interface card, which will come in the next layer, that is our network layer, right? So now what has happened is we initiated a session, we used the transport layer, and in transport layer what you have done is you are trying to send a packet based on TCP. Do not assume the current email going via UDP. Let's take it as TCP because email requires that TCP session where acknowledgements will come back or no, right? So now here we come to TCP. This TCP will use some protocol according to the data what you were sending. So we were drafting email, right? When we were drafting email, we use IMAP protocol or POP3 protocol, right? These protocol has their own numbers. So for IMAP, I think it is 110, and for POP3, I think it is in the 90s. I'm not sure about this, but let's assume. Let's assume that the TCP port for IMAP is 110, and for POP3 it is 90. So let's say we are sending the Gmail email. So Gmail uses IMAP. So this IMAP has a TCP port of 110. Now this packet, whatever we were sending, that will be attached with the 110 port, right? Now this 110 port is done. So until fourth layer, the job is done. Now, how will you send the packet to the next end host? So let's say you are drafting an email to me. I am sitting here in India somewhere, and you are sitting in India somewhere. Now it has to go through the network layers, right? Using the routers. There are multiple routers. There are multiple ISPs. So I am currently using Act FiberNet for internet. You might be using Tata or BSNL or something like that. So from any ISP, it has to come to me. From you, that is A, to it has to come to me, that is B, right? So how will this user send the traffic to B? It is simple. Somebody mentioned from the team as well that IP addresses, right? So let's come back to our example of courier boy. Now this courier boy, he knew initially the IP address. He knew the address, that is this gated community's address he was aware of, but he wasn't aware of the exact house number of B, right? So this exact house number of B is something we assume it as TCP port, right? TCP port, and this address here is the IP address. So this courier boy reaches to the IP address, and according to the port it has to deliver the parcel to, it sends the delivery to the A block resident, that is B. And the packet reached properly because it was acknowledged by a sign. So this sign went back to the user A. I hope this is clear now. What is IP address and what is TCP? Or did I confuse you here? Any doubts?
Like IP address, access address, and TCP will tell where to go. That's it, right?
Come again?
Like IP address, access address from
Yes,
here to there, and
yes.
TCP port will just deliver like like a person.
Exactly, exactly. That's right understanding. So what IP addressing is doing is its job is to send the packet to the destination on the layer, on the network layer only until the router. Now this router's job is to send that packet to the exact port what the user's device will be able to comprehend. So I told you just now that there are about 65,000 ports on a user machine, and IMAP is using 110 protocol number, right? So how will B know that this particular protocol, whatever it has to be comprehended as an email? It will check the TCP port 110. Once it sees that okay, it is TCP port 110. Okay, this is a Gmail. Okay, let me show the user how. Let me just decrypt all the packets using the presentation layer, and in the application layer I'll show him the email. So I'll come back to the reverse flow shortly. But basically the basic gist of IP addressing is the network layer. In the network layer, the IP addressing is the basic gist, how the packets will flow. So let's say this particular address of this particular user is 1.1.1.1. This is IPv4 addressing. We'll come back to addressing the IPs and how they are addressed later on as well. This is IPv4 addressing. It will go to this particular router which is hosted on this IP. This you can see from 1.1.1.1, its destination has changed to 1.1.1.2. Then it goes to 1.1.1.3, from there to 1.1.1.4. Like that, slowly it is finding the route to the B. So it found that route is like this. It has to go to 1.1.1.2, then to 3, then to 4, then it will reach to the destination 1.1.5. Here, once the packets reach here, according to the TCP port, the packets will be comprehended on the user machine. So we'll come back to that shortly. Now, once it is in the network layer, the next important layer is the data link layer, right? So the job of data link layer is completely physical. It's completely dependent on the physical address of the devices, physical address of the networking devices what we are using. So here also we use a networking device called as router, right? At home we have Wi-Fi routers, right? We like TP-Link or some or the other vendors, we have routers at home. So those routers will have a MAC address. Not only routers, your smartwatches, your mobile phones, each and every device has a MAC address, right? So what's the job of this MAC address? The MAC address job is to get a physical address. So let's say you are aware of this IP address. Let's say you are aware of this IP address, but are you aware that to which device you have to send the packet to? Because on the same IP address, there can be multiple routers. On the same IP address, there are multiple routers. How will you know that you have to send the packet to the correct device? So that job will be done by this data link layer. What it will do is it will send the packet to the correct router using the MAC address. So MAC address is in the format of FF, FF. We'll come back to each and every layer protocol in detail later as well. So it stays in this format, or otherwise I think I can show you that. Just a second. Right. I think you are able to see the screen. Okay, I don't think so. Let me just present my command prompt screen. Okay. I believe you will be able to see my command prompt screen now.
Yes.
Yes, sir.
Right. So if you see this, this is my device here, right? So here we see get Mac. I ran a command on my machine as get Mac here, and we see that the physical address of each and every device. So each and every, see these two medias are disconnected. That is, I'm not connecting it, but still it has a address here. So this is how the data link layer or the physical layer addressing actually works, right? So this is about how your packets will arrive and to which particular physical network layer, to which particular adapter it has to go, because this is my device. These are called as adapters. If I do ipconfig, so you can see there are n number of adapters here. Let's see this particular adapter, that is wireless LAN adapter. It is currently in the disconnected state, right? And it has its own physical address here. I think we saw the same address here, this one. So this is how so what adapters I'm showing you here are the network layer, the network interface card, which have their own physical address in this format, that is MAC. That is called as a MAC address. So this is about that. Now let's come back to the next layer, which is our physical layer. Right. So I believe you are able to see the screen, the notepad screen. Yeah. So the next layer after the data link layer is our physical layer. Right. What does physical layer do? Physical layer does nothing, it's just wire. It's just the cables. It is just the cables here. So these cables are attached between your Wi-Fi routers, right, to send the data. Now you are connected wirelessly. That's okay, but your routers at a later hop or at a later stage are connected via these links. Those are cables. Now, once these cables are connected to each other via routers like this physical layer job is to get all this data, 2, 3, 4, 5, 6, 7, these 7 layers, overall all the data, and convert it into bits like this in zeros and ones. So if you cut a cable here and start running a packet capture on it, you will see the data in this format. You will not see a data in in like this format. So when the data is traveling, it is in this format. I believe everybody is aware how actually data is comprehended. Everything is in binary like this. This binary data, once it goes, so we were talking about email, right? So you drafted an email. Once you draft an email, the next job, the final job from your computer. So you were drafting an email, you drafted the email, you sent it, you clicked send. This all things were done within your network only, within your home router only. This all details were done. Now from physical layer, it goes to your nearest ISP. ISP is nothing but internet service provider. Let's say in our case it is Act Fibernet, right? So it goes, these all packets go to Act Fibernet. What will Act do? This Act, it will check what is the next hop to send the packet to the B. Now using that physical layer only, when the packets come to B, the same flow which we came from application layer will be reversed and will be from physical layer now. So first the packets will come via the cable to the physical layer, then it will go to the physical addressing, that is our MAC address. So here the data link layer, will be there. Then third layer, the router's job will be to send the packet to the correct address. So once it comes to my ISP, let's say Act Fiber is sending the traffic to Tata ISP here. Once the packets have come here, it comes here, and then according to the network layer, which is my internal home router, it reaches to my address here, and then using the TCP. So whatever data I am sending, it is not yet decrypted, right? So until now, I cannot see the email on my screen. What is happening is now TCP checked that, okay, this is a 110 protocol. So this means that this is an IMAP protocol. What it will do, it will send the packet to the session layer. Now this session layer sees that there is an ongoing session already with this particular connection or this particular email channel ongoing there. Once that is happening, it will send the packet to the presentation layer. So as the name also suggests, it is presentation layer. This presentation layer will check that this is 110 protocol and this is an IMAP. It tries to decrypt the packet now. Whatever compression happened here, if you see while sending, we did compression and we encrypted it. Encryption means we are trying to lock that, or we are trying to create a hash of it so that any other user cannot modify it, right? So that job we are trying to decrypt it now. That is, we are trying to decipher what was there inside that. So what does decipher mean? Decipher means trying to understand what is the data, right? So once these packets, whatever are encrypted or completely hashed, will be decrypted in the presentation layer. Presentation layer will then send the traffic to your application layer, which is your system, which is your Gmail, right? When you click Gmail and you click your inbox, emails and all, that is where you are able to see the email there. How are you able to see the email there? Using this whole process. So from application layer, your traffic was sent. That is, somebody created an email, they sent it to you. It came to their own physical layer. From there, along the path, it went at each and every router. At each and every router, this whole step happens. That is, all the data will go to this router. From here again, it will go to this router. From here, it will again go to this router. Then it will come to you, and then the reverse path. That is, whatever was decrypted and encrypted, whatever was encrypted and hashed, that will be decrypted here, and you will be able to see the email. So none of these users will be able to see the traffic. None of these people. Only you will be able to see it, and the person who sent the email will be able to see this. And this is possible only because of the presentation layer, which has the capability of encrypting the packets using the TLS protocol, right? So this was how the OSI layer actually works. So this was just a basic brief how it will actually work. Each layer has its own definition, has its own understanding, and there is what I wanted to show you is a very pictorial way, not to go in wording format, right? That's the reason why I chose this path now. I just have one question for you guys. Any doubts on this particular thing, the packets we sent and the packets we received?
Sir, what is TLS?
So TLS is an encryption standard protocol, right? It is
Okay.
transport layer security protocol. What
Okay.
it will do is it will encrypt the packets in the application layer itself.
Okay, like our WhatsApp messages.
Exactly. Exactly.
Okay.
So there are different encryption standards as well. So according to the encryption standards, these packets will be encrypted. So TLS in its own has multiple encryption standards. There is 128 bit of encryption. There is 256 bit of encryption. I believe every one of you use WhatsApp. So when you use WhatsApp, you will see that the messages are end to end encrypted. What does that mean? That means that only the person who is sending the message and the person who is receiving the message is able to view that message. and none of the other parties are able to see it. And this is only possible because of TLS, right? So, what I'll be
Sir,
doing
in
is
TLS break, you mean we can break the encryption? Can we break?
encryption break means, what do you mean? I didn't get you.
Can we break the encryption so that we can uh, like can we break? You have told me multiple encryptions,
Mhm.
like 128 bit. Will
Yes.
that breakable? That any person can break that encryption?
Yes, exactly. They can do that. So this is what we call as hacking.
Yeah.
So what do hackers do? Hackers' job is nothing but to decrypt this encryption. Whatever
With hashing
encryption.
codes?
Yeah, go ahead.
With hashing codes as well?
Yes, with hashing also. There is nothing on the internet which is not hackable. Everything is hackable. So that's a completely different uh,
Yeah.
concept. So that is completely under cyber security and all. So if we see the encryption standards here, that is 120 and 256, because you bought it out, I'll just give a small brief. This 128 bit and 256 bits are the encryption standards that is recognized by the INA, right? So this particular encryption standard, whatever is there, these are nothing but maths. It's completely mathematical logic for breaking whatever encryption you're doing. Encryption, what it does is it applies equations to your packets, to whatever traffic is being within that particular uh, time. At that particular time, let's say you're sending an email. When you send an email, it is passing through multiple routers, multiple users are there, multiple ISPs are there. If they start looking at each and every packet, they can see what you are sending to this B user, right? So when this standard is used, when this encryption standard is used, the traffic is encrypted here using the presentation layer, and then the same is decrypted by the B user using the presentation layer, because these both know what standards they have used for encryption and decryption, right? This is a concept which will come later during the course. I'll bring this concept of SSL and TLS. At that moment, I'll explain you how it actually happens, and how these packets are encrypted and decrypted. So that's not a problem. So I just want a confirmation from each one of you whether you have understood what we have learned today in the class. I know that it's a big concept and I have given very in-depth information for each and every layer and all. But I just want to understand if each one of you have understood it or not. You can unmute yourself and tell, not a problem. Nobody's there.
Yes, sir. Understood.
Yes, understood.
Yes.
Yeah, understood.
Okay. So basically, once the classes end, I'll what you can do is you can search for the same thing on Google, right? You can search for OSI model on Google, do your own research, make notes of that, and during the start of each session for 10 to 15 minutes, we will have the discussion on each and every concept what we have discussed in the previous class. So one by one, you will all have to give basic explanation of what we have gone through today, tomorrow, right? So today, what you can do is you can surf internet regarding OSI. That's it. So this is something which is the core standard of networking and very important concept. And each one of you will have different understanding, different explanation of each and every layer. But all in all, it will be same. What I want you to do is you do your own research at your end, create a document of OSI, and tomorrow one by one you can present your screen and each layer explanation you can give. Accordingly, you will have doubts. We will clarify that those doubts in that session.
So detailed explanation or
You can explain briefly. There is no detailed information required. Nothing is required on that sort. Once you're done tomorrow, if there is anything missing which you will have to learn on that concept, I'll add to that, because you just have to understand how we have just went through the course. I know this is a little bit confusing. What is IP address doing? What is MAC address doing and all? Slowly you will understand that based on the practical things what we will be going ahead. So before we wind up this session, I think it's already been 1 hour. Okay, not a problem. So before we wind up, I will just show you how the packet captures look like. Just a second. We insist on downloading Wireshark. Have you downloaded Wireshark? I think last class you were informed to download. Great. So I'll whatever explanation I had just given, I'll just show you how it looks like when you actually troubleshoot issues, or maybe once you open Wireshark and check. Right. So this is how the packets will look like when the traffic is actually flowing. Right. So let's say this packet is going from where to where. See, you can see the source address here. This is the network IP address, right? And the destination is this 35.190.225.25. And you see source port and the destination ports as well here, and the protocol is TCP, right? So let me click on this particular packet here so that we can see how the all these layers come into picture. Now we learned about OSI just now. So in OSI we learned when the packets are being sent, they come from the layer 7, right? Whatever data is there. Now you can see here transport layer security. Here we do not see the exact reference of OSI. The reason being, we do not use the exact reference of OSI, we use the DoD model, right? In that model, what we use is we use the application layer, transport layer, IP layer, data link layer, and the physical layer. That's it. So if you see here, the transport layer, it is carrying some packets into it. What kind of packet it is carrying? It is carrying a client hello packet. So this is the application layer. It comes back to the transport layer, right? Now here you can see the source port and the destination port. We will come back to each and every header into this, and you will have to actually by heart those as well. We'll come back to the next session when TCP topic comes, but I'm just giving you how Wireshark can help you learn things here, right? Then next is the internet protocol. That is our network layer. This is the TCP, that is our transport layer. Then comes our network layer. Then comes our Ethernet, that is our data link layer, where we can see the destination and the source MAC address. You can see the MAC address here. This is the TP-Link PT. This is the device they are using, and its MAC address is this. And they are trying to from this source, from this MAC address, they are trying to send the package to this. This is how the destination will understand to which particular device the traffic should go to, right? And then comes our frame, that is our what do we call the wire, the cable. So how many bytes of data is on wire, you can see here as well. So this is just this is how actually in working OSI model looks like. This is the reason why you have to learn OSI model properly, and then only you will be able to interpret each and everything in a proper format. Otherwise, there is no use of learning OSI model, right? I think you have got a brief of this. Okay, so yeah, so what we can do is for tomorrow, you can research at your own end. You can research regarding OSI model, and if you have further some more time, then go ahead with Wireshark, open Wireshark, try to understand how the packets are capturing and try to map it to the concepts what we have gone through, the OSI concepts, right? Anything else before we wind up?